Profit maximization in perfect competition. We are going to use this opportunity here to actually say a few more words about profit maximization in general. Because this is going to be the leitmotif for each and every market structure we are going to discuss, whether it is perfect competition or pure monopoly or oligopolistic market or any other. We assume that the goal of a business is to maximize the profit, to gain the profit and to make it as big as possible. How is it done? Have a look at the slide here. Profit, pi, is defined as a positive difference between total revenues and total costs. As you can see, both total revenue and total cost depend on quantity. What does that mean? Well, when you look at total costs, it is pretty obvious that the more you produce, the greater are your total costs. You need more people, you need more materials, you need more energy, you need more. To produce more, you need more. So no wonder that total costs depend on Q, or we could say they are functions of Q. They are a function of Q. And if you refer to the lecture on cost, you will see that depend on quantity produced. Then we've got total revenue, and as you remember, total revenue is P times Q. Therefore, we could say total revenue is also function of quantity. But here is the thing. When it comes to total costs, they do depend on quantity produced. This is production that generates costs. When it comes to total revenue does not really depend on quantity produced, but it depends on quantity sold. Only what you sell generates your revenue. So P times Q is the price at which you sell times Q, the quantity that you sell. In the equation here, you have TR depending on Q, and you've got TC depending on Q. It seems to be the same Q. Hence the question, can we actually assume that quantity produced and quantity sold, are they the same? Can we assume that? Well, the logics would say, no, not really. I mean, not everything that you produce will be sold. Therefore, no, that's not the same. But if you think more carefully, then you will see that for more businesses, this kind of assumption that quantity sold is equal to quantity produced is pretty reasonable. If there is a business, someone produces tables for the last 10 years, and over those 10 years, they produced 20,000 tables. Then the question is, how much did they sell? Over those 2 years, over those 10 years, they produced 20,000 tables, and what did they sell? Just 1,000? And they still have 19,000 in their warehouse? No, that's unlikely, right? That's unlikely. We are going to assume that quantity produced and quantity sold are almost the same. So technically, they are the same, not because we believe that whatever you produce, you will sell. No. But we do believe that actually you want to produce, you try to produce as much as you can sell. So it's not production that creates sales. No, it's more sales that tells you how much to produce, right? So businesses try not to produce more than they sell. Hence, we assume, we are not 100% precise here, but we assume that for our needs, making this quantity sold and quantity produced equal is pretty okay. So if total revenue depends on quantity produced and total costs depend on quantity produced, then obviously the profit, pi, also depends on quantity produced. So we could say profit is a certain function of Q. And we want to maximize profit, so we want to maximize this pi. We want to maximize this function. How do we calculate or how do we find maximum profit, maximum function? We know that the first derivative of the function should be equal to 0. Then we get the extreme point of this function. So that would be our maximum profit. So if you look, this is what we do actually here. So we calculate the first derivative of pi and we equate it to 0. So since pi itself is total revenue minus total cost, then we take the first derivative of total revenue that is equal to the first derivative of total cost. Because if those two derivatives are equal to each other, then the derivative of pi is equal to 0. And this is what we want to happen, because for this derivative equal to be 0, we've got maximum profit. So our condition for profit maximization is that the first derivative of total revenue is equal to the first derivative of total cost. Let's have a look at those derivatives. And let's start with the right one. The derivative of total cost with respect to quantity produced is something that we already know. That is the formula that allows us to calculate marginal cost. So the first derivative of total cost with respect to production is marginal cost. We could use it and produce a kind of analogy here. If the first derivative of total cost is marginal cost, then we could say the first derivative of total revenue is marginal revenue. Whatever it is, actually, right? We will explain it slightly later. But this equation at the bottom on your left may be translated into the equation at the bottom on your right. Marginal revenue is equal to marginal cost. And when marginal revenue is equal to marginal cost, the profit that we get is as big as it is possible. You see, I call this slide general considerations on profit maximization. Because in fact, this slide stays correct for any market structure. So whether this is perfect competition or pure monopoly or oligopolistic market or a monopolistic competition or any other market, this slide is kind of always correct. So this is the universal recipe for profit maximization. Make marginal revenue equal to marginal cost. If you accomplish that, your profit is as big as it is possible. Marginal revenue equal to marginal cost. Let's have a closer look here. We already know marginal cost. Marginal cost is the additional cost that is incurred if you want to produce 1 unit more, right? So this is the cost of this 1 additional unit of your production. What is marginal revenue? Well, that's pretty analogical. You get revenue from selling your products. So marginal revenue is the additional revenue that you get from selling 1 unit more, 1 additional unit of your production. If we define marginal cost and marginal revenue in this way, then obviously the difference between marginal revenue and marginal cost would be marginal profit. Again, marginal revenue is additional money that you get from selling 1 unit more. Marginal cost is additional cost that you get if you produce 1 unit more. So the difference between them is additional profit that you get. So if you decide to produce 1 table more, this will cost you additionally marginal cost, and you will get from selling this additional table marginal revenue. If this marginal revenue is bigger than marginal cost, then this additional table will add to your profit. So you will have your profit bigger by this additional value coming from producing and selling 1 additional table. So as long as marginal revenue is bigger than marginal cost, it is reasonable for you to keep on producing and selling, as long as marginal revenue, what you get, is bigger than what it costs you. And the signal to stop your production, to not to produce more, not to sell more, is when marginal revenue equals marginal cost. Then what you get is actually equal to what you have to spend, so there is no need to produce additional units. So you do not increase your production, you do not produce additional items. So everything that was said so far is pretty universal, as I mentioned. But this is the moment when we focus again on perfect competition, and when we say, okay, there is something special about perfect competition. And what is special about perfect competition is the fact that marginal revenue does not depend on your production. In all other markets, marginal revenue depends on how much you produce and sell. But perfect competition is different from other markets in the sense that in perfect competition, marginal revenue is precisely equal to the market price, to the price that you get from the market. It is easy to understand when you refer to our example of you selling euros in the exchange office, right? Because for each additional euro, you will get additionally some money. How much money? Well, this is precisely the money equal to the price. So if the exchange rate of euro against Polish zloty is 4.2, so for each additional euro, you would get 4.2 of Polish zloty. And this is your marginal revenue, and it is equal to the market price. So this is something special for perfect competition. Instead of saying marginal revenue must be equal to marginal cost, in perfect competition we can actually say the price must be equal to marginal cost. And we already know that you don't have any control over this price. So your way to maximize your profit in perfect competition will be about adjusting your marginal cost to the price that is in the market. So you manage your business on perfect competition market simply by adjusting your production. Adjusting your production so that marginal cost is equal to the price that currently is present in the market. That's how you manage your business on perfect competition market if you want to maximize the profit. Okay, let's have a look at the profit and how it may be maximized. You can see profit maximization in perfect competition here. And what you see in this graph is total revenue function. You can see this is a linear function. This is simply a straight line. Because it is P times Q, total revenue is P times Q. So if you look at your revenues from, let's say, selling euros, then with the exchange rate of 4.2, total revenue is 4.2 times Q. And this is this line here, right? Starting at the very origin of the coordinate system and just a straight line. Then the second curve that you can see here is the curve of total costs. And this is a typical case, typical shape that you can see here. So there are 2 points of intersection. And those 2 points of intersection show us 2 break-even points. So there is a clear distinction here. You can speak of 3 ranges of quantity produced. So from 0 to this QL level, this is lower break-even point. For all this range, you will see that total costs are above total revenues. So this is economic loss that is here, right? But if you come closer and closer to QL, the distance, the difference between those 2 curves gets smaller and smaller and smaller. Actually, when you produce and sell QL, then your total revenue equals to your total cost. Therefore, you break even. So you get 0 profit, and this is, remember, 0 economic profit, and this 0 economic profit allows you to operate your business normally. If you produce more than QL, but still less than QU, then this whole range of production gives you profit. So whatever you produce between QL and QU, you've got profit, some profit. Sometimes bigger, sometimes smaller, depending on your production, but this is basically the area of profit. And if you exceed QU and you try to produce more, then you can see that actually your total costs take off, they kind of skyrocket there, right? And they become bigger and bigger, much bigger than total revenue. So this is the area of economic loss again. So for your business, well, you need to stick between QL and QU for the profit. And obviously, you are interested as the manager, as the owner of a business, you are interested usually in having the biggest possible profit. Therefore, you are going to look for the production. This is optimal level of production in my slide. You are going to look for this optimal level of production, economic optimum, for which the distance between total revenues and total cost is as big as it is possible, because this distance is your profit. So we're looking for profit maximization. This profit maximization can be actually captured very well in this graph here. This graph is better in the sense that it operates with the price level, this horizontal line that you can see, average and marginal cost. So since we already remember that profit maximization in perfect competition market is about making marginal cost equal to the price, you don't have any control over the price, but you do have control over your marginal cost, because this cost is bigger for bigger production, smaller for smaller production. So you can actually set your production to Q optimum and this Q optimum allows you to have marginal cost equal to the price. So in other words, it allows you to maximize your profit, right? In this graph, you can also see those break-even points, QL and QU. They are just the same as they were in the previous slide, in the previous graph. Additionally, what you can see here is minimum AC and the corresponding quantity produced. And here we refer to something that we learn during our lecture on costs. This QT is technological optimum. So this is the optimum from the technological point of view. This is the level of production at which you get the lowest average cost of production. As you can see, this technological optimum and economic optimum, QOpt, these are two different things in this case, right? So technological optimum doesn't have to be equal to economic optimum because these are two different perspectives, right? For economic optimum, we want the profit to be as big as possible. For technological optimum, we want production to be as cheap as possible. This could be the same, but doesn't have to be the same. The comparison between profit maximization and technological optimum is given here with this slide. So you can clearly see a comparison between those two. What are the similarities? What are the differences? First of all, let's be able to see, to grasp the profit. How do we find profit in such a graph? Let's focus on Q optimum. This is our economic optimum, right? So when you produce Q optimum, you sell it to the market at the price that is P, then obviously your profit is this rectangle given by P. This is the vertical dimension, and the horizontal dimension of this rectangle is Q optimum. So this whole big rectangle here is your total revenue. When it comes to your total cost, you find them by putting Q optimum in the AC curve. So you get AC for the optimum production. This is the average cost. And again, those total costs can be found here in the graph as a rectangle with a vertical dimension being AC for optimum and the horizontal dimension, like previously, this is Q optimum. So what we so far have is one big rectangle, P times Q optimum. This is the big rectangle that shows you total revenues. Then we've got this smaller rectangle with horizontal dimension of Q optimum and vertical being AC optimum, right? So this is the smaller rectangle. So the rest of this big one, what's above cost, is our profit, as the slide shows you, right? And for Q optimum, remember this upper rectangle is the maximum profit, the profit that is as big as it is possible. For technological optimum, we will see that production is much smaller. The vertical dimension of costs is also smaller. So you could say this rectangle at the bottom, total costs for technological optimum. Well, that's pretty low. But the length of this rectangle is also smaller, right? So the whole set of rectangles for optimum, technological optimum is shorter, right? And that makes this profit for technological optimum smaller than maximum. right? So if you want to maximize your profit, do not stick to technological optimum. Don't take technological optimum. In some cases you may, but generally speaking, don't do that, right? You can also see unit profits here. This unit profit is the difference between the price and average cost. And here, obviously, we see that for technological optimum, this unit profit is as big as it is possible, right? If unit profit is the difference between the price, and the price is a horizontal value, right? This is a horizontal line. And this is the difference between the price and average cost. Then for technological optimum, this average cost is as low as it is possible, so the difference is the biggest possible, right? But we never want to maximize unit profit. We are not interested in getting a very high profit from selling one unit. No, we are interested in total profit from our whole production, from the whole sales that we make.